Hi everyone, hope you guys are doing well. So here we have a grade 11 Mathematics Paper 2 exam written in November 2015, 150 marks and 3 hours long. These are all the questions that we're going to do, but I'm going to be splitting them up over different slides just so that we have more space to write. Okay, so those are the 7 questions. So let's begin. The table below shows the weight to the nearest kilogram of 27 participants in a weight loss program. Okay, calculate the range. Okay, so the range is always the highest minus the lowest, which would be 156 minus 56, which is 100. Write down the mode. The mode is the value that appears the most. So it's the number that you see the most often. Okay, so let's have a look. I see that there are two 71s. Let's just see if there's any other numbers that are repeating. No, it's just that. Okay, so that would be the answer, 71. Determine the median. Okay, so the formula for median is n plus 1 over 2. So how many people are there? There are 27 people. Okay, so we'll say 27 plus 1 over 2, which is 28 over 2, which is 14. That's not the answer. That is the position. So we go position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would be the answer, 93. Determine the interquartile range. Interquartile range, which I'll just call it as IQR, is the upper quarter, which is Q3, minus the lower quarter, which is Q1. Now, we need to go find each of those. So to find Q3, well, let's start with Q1. To find the lower quarter, you say n plus 1 over 4. Okay, so let's do that so long. So that's 27 plus 1 over 4, which is 28 divided by 4, which is 7. But that's not the answer. We must go to position number 7. So we go to position number 7. So 1, 2, 3, 4, 5, 6, 7. So that's 82. Okay, so that's Q1. The formula for Q3 is also n plus 1 over 4, but then you multiply that with a 3. Like that. Okay, so that's going to end up giving us, if you had to go work it all out, you should get 21. That's not the answer, that's the position. So we go to position number 21. Now, I'm not going to waste your guys' time counting all of that, but it should be 19, 20, 21. It should be this one over here, 127. Okay, so we have Q3 and we have Q1, so now we can say the interquartile range is just going to be 127 minus 82, and that would be 45. Moving on, use the number line provided in the answer book. Okay, so they probably would have given us a number line to draw a box and whisker diagram for the above data. Okay, so a box and whisker, right, has 5 different things. Let's write those down. 1, 2, 3, 4, and 5. Okay, I can't fit that in. Hold on. 1, 2, 3, 4, and 5. So this is what a box and whisker has. It's got 5 different parts. It's got a minimum value, a maximum, and then it's just got Q1, then it's got the median, and then it's got Q3. Okay, so what we do is, they would have given us a number line, but let's just go draw our own number line. All right. So what we do is we go to, I decided to just go get the number line. Okay, so the minimum value. So the minimum value is 56. So be careful here, 52, 54, 56, 58. Okay, so that works out. So they're going up in 2s. So 56 would be here. So we put a little line over there. Let's go to the maximum value. So we've done the minimum. The maximum is 156. So that would be over here. There we go. Okay, now Q1 we already worked out as 82. Remember that? The median we worked out as 93. And then Q3 we worked out as 127. Okay, so Q1 is 82, which would be here. Median is 93. Okay, so that's going to be in between those two lines. So it would be like that. And then 127 would be 122, 124, 126, 128. Okay, so it'll be in between these two lines. That would be like that over there. And that's it. Now what you do is you take the middle 3 and you just make a nice little box. Okay, mine's completely off there. More like that. And then you just complete that little box. Come on, Kev. There we go. And then you just connect the little whiskers over here. And over here. Boom. Okay, so that is our box and whisker for 2 marks. Geez, like these people are stingy with their marks. Okay, now it says determine the standard deviation. Okay, so now this is all calculator work. Oh my goodness, we have to go put all of this on the calculator. How stressful when you're in an exam. I remember, it's like, am I forgetting one? Have I entered the values correctly? I don't have time to go check again. Alright, but let me show you guys what to do. So, let me just make sure. Okay, so we're going to put our calculator into stats mode. So we say, you might have the blue, pink, or black calculator of the Casio. I've just got the silver one. But you're just looking for, you're going to press mode, and then you're looking for the button that says stat. And then you're going to look for the one that says 1 minus VAR, which is, in my calculator, it's a 1. And now we're just going to go into these 5 million values. My goodness, because we always have so much time in the exam. Okay, so I'll see you guys later. I'm just going to go into all these values. With the 71, you can just enter the 71 twice, okay? Some people have a second column called frequency. If you do it like that, then you just put 71, and then in the frequency, you'll just change it to a 2. All right, guys, and 4 hours later, I am nearly done. 144, 156. Thank goodness. Okay, so once all the values have been entered, you're then going to push AC. Then you're going to go to Shift. Okay, then you're going to come down here to your number 1 on your calculator. You can see it just above there, it says stat. That's what we want. So you push 1, and then you're going to go to 4, which is VAR. And then we're looking for the weird button, which on my calculator is number 3. It's the number 3 option over here. It's got that weird like little apple with a little, I don't know what that thing is, but it's the one with the X and the little circle over there. Okay, so it's number 3 on my calculator. That is called standard deviation. Press equals, and there we go. 25,84 if we round that off to 2 decimal places. So we can just say 25.84. You don't have to show any working out for that one. They know that you're using the calculator. Yes, there is that other long method that they probably showed you in class, but you're never going to have to do that in an exam. Maybe in one of your school tests. Some schools are a bit weird and they want you to do that, which I think is quite stupid. But for the most part, they just ask you to use the quick calculator method. All right, so that's that. 1.7. The person who weighs 127 kilograms states that she weighs more than 1 standard deviation above the mean. Do you agree? Motivate your answer with calculations. Okay, so they said more than 1 standard deviation. Okay, so we at least calculated the standard deviation as 25.84 in the previous question. Above the mean. Haha, so we need the mean, okay? So the mean is the average. But now, if you haven't cleared your calculator, then you are lucky because you can actually get the mean straight from your calculator. If you have cleared all of the values from your calculator, then you would have to go add all of these numbers together. You know how to calculate the average, right? You add all of these numbers together, and then you divide by 27 because that's how many numbers there are. But for those of you that still have the values on your calculator, then what we're going to do is the following. I'll show you what to do. Okay, so this is still where I got the mean. So what I'll do is I'll just press AC again. So the values that I've entered are still there. Can I actually just show you guys something? There is a way that you can see your values. So the way that you can still see if your values are there, you just press Shift, and then you go to 1, and then you go to number 2, which is data. And there they all are. See that? So you can modify them or see if you've done them correctly. I remember when I was a student, I didn't know this, so I would literally go do everything twice just to make sure. But if you're in a test, guys, just press Shift, 1, and then data. And then you can just go check, and you can see that you've entered the values correctly. Okay, so those values are still held on the calculator. So to find the mean, we can just press Shift 1. We go to number 4 again. Now it's that option number 2 over there with the X with the line at the top. That is another thing for mean or the average. Press that one, and there we have 98.59. So the average is 59. Okay, so that's your average or your mean. Okay, so this person says that she is more than 1 standard deviation above the mean. So what we do is we know that the mean is 98.59. So if we add 1 standard deviation onto that, how much do we get? 124.43. Now this girl is 127. Yes, so she is more than 1 standard deviation above the mean. So do you agree with this person? Yes, we do agree with this person. And then you would have showed all of your calculations like that. The table below shows the weight in grams that each of the 27 participants in the weight loss program lost in total over the first 4 weeks. Okay, so let's just try and get an idea of this. So there are 2 people who lost between 1,000 and 1,500 grams, for example, and then there are 5 people who lost somewhere between 3,000 and 3,000, and then there's 1 person who lost 4,500, or somewhere between 4,500 and 5,000 grams. Okay, so that's sort of how that table's working over there. First question, estimate the average. Okay, average, so that means the mean in grams. Okay, so we need to know how to calculate average from a table. So the way that it works is there are 2 people over here, but you got to take the mass as somewhere directly in the middle. Okay, so the mass in the middle would be 1,250. This one would be 1,750. Okay, so there are 2 people who weigh. We can actually do this on the calculator. I'm just thinking, should we? Yeah, we can just do this on the calculator, because remember, there is a way that you can calculate the average using your calculator. So the way that would work, let me quickly show you. So what I would tell you to do first is to open up the frequency column on your calculator. So the way that you do that is okay, first of all, let's put our calculator back into the normal mode. Okay, so first step, put it into stat mode, like that, and then go to option number 1. Now go shift mode and go down to stat. So you have to click down to stat, which is number 4, and then put the frequency column on. So say number 1, so it's on. There we go. Now, for the first one, you're not going to use 1,000. You're not going to use 1,500. You're going to use the number in the middle. So 1,250 equals. But now, in the frequency column, there are 2 of those people. Okay, so what I'm going to do now is I'm just going to go fill in all of the values on this calculator. I'll see you guys soon. Well, not see you guys, but I'll be with you guys soon. So there we go. I've entered in all the values. So we want the average, right? So what we do is we go to, you push AC, then you go shift 1, and now we're going to go variance. And now we don't want the standard deviation. We want to go for number 2. Okay, which is the X with the line at the top. That is another name, or another symbol, sorry, for average or mean. So we press that one and we say equals. And there we go. 3009.26 if we round to 2 decimal places. 3009.26. Okay, and that makes sense. I mean, the average is usually somewhere here in the middle, because that's usually where there's more people. If you look there, 4, 5s, and 7s, whereas these ones are 2s and 1s. So the average is usually somewhere here in the middle, and that is around 3,000. So if our answer was like 1,000, then you know something's not right. Okay, and then if you didn't want to use the calculator method, you would have to say 1,250 times 2 plus 1,750 times 3 plus 2,250 times 3. And you would go on for all of those. And then at the end, you would divide by how many people there are, which is 27. But that's also the same if you add these up. That'll also be 27. And that would give you the exact same answer. Okay. Okay, so draw an ogive on the data on the grid provided. Okay, let me go get the grid for us. All right, so there's the grid. Okay, now when we do a cumulative frequency, there's 2 main things I want to mention to you guys. Number 1, we don't use the frequency. Instead, we use something called cumulative frequency. So let's quickly go work out the cumulative frequency in this little column over here, which I'll make, and we'll just call it CF. But it's called cumulative frequency. So the first row is always the same, so that's 2. But then you plus, so 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 4 is 12. 12 plus 5, 17. 24, 26, 27. And there are 27 people, so that makes sense. We've done that correctly. Now, the next thing, okay, so you don't use that. The next thing is a lot of students, they want to use these values that are in the middle, like we did when we calculated the average, but we actually don't. We use these values. Okay, these are the values that you use on an ogive curve. It's the ones at the end, and then you're going to use these values as your y-axis. And then another thing is you don't always start at the 0. You actually start at this number over here. So whatever that number is, that's your start. Okay, so there's actually a lot of important information here. So we start with that number, then we use those numbers, and then we use the cumulative frequency. Okay, so we go put a little dot at 1,000. That's always step 1. Now we're going to go to 1,500, and the y value there must be a 2. Okay, so we go to 1,500 and we go up to 2 and we place our little dot. See that? Then we go to 2,005. So 2,005, we place a little dot over there. And then we go to 2,508, like that. And then 3,012, 3,517, 4,024, and then 4,526. And 5,027. There we go. Then you're going to neatly try and draw a line or like a nice curve going through all of those, and it always does this type of shape. Should always do something like that. Then you know you've done it correct. Okay, so up like that, and then it goes flat or flattish. All right, so there I've gone and drawn mine. Okay, so that's the ogive. Draw an ogive, blah, 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 blah. Okay, now the next question. The weight loss program guarantees a loss of 800 grams per week if a person follows the program without cheating. Hence, determine how many of the participants had an average weight loss of 800 or more over the first 4 weeks. Okay, so now in these types of questions, you're going to use the ogive. So they want to know, I was a bit confused. I was like, 800? But everyone lost more than 800. But this caught me out. This one says over 4 weeks. This one says 800 grams per week. Okay. So if you had to multiply this by 4 to see how much it would be over 4 weeks, it would be 3,200. 3,200. So they want to know who lost 800 grams per week or more. So 3,200 over a 4-week period. So how many people did that or more? Now what's interesting is we can't use the table. They want you to use the cumulative frequency graph. Let me explain why. If you use the table, you only have access to the people who are more than 3,000 or more than 3,500, but you don't get access to 3,200. But on a cumulative frequency, you've got access to everything. So you can just go to 3,200, which is somewhere between here. It's probably there. And then what you do is you just go up. Now remember, they do give you a range of values you can get as an answer. There we go. And then you go to the side. And you get to about 13. Now, if you got to 14 or 12, they would probably still mark that correct. Okay, but now don't say that that's the answer. Be careful. We know that that's 13, okay? But sometimes you have to minus. So they want to know who lost more, okay? So would that be these people? Or would that be these people? Well, it would be these people because they lost 3,200 or more. So we want to know how many people are here. So we want to know how many people are here. Because look, if you go up, then you go to the side, that's where it goes, right? If you go up here, and then you go to the side, that's where it goes. We don't want to know these people, okay? Because that's these lower values. So, okay, so there were 27 people in total, not 28, right? It's not always that number. Our graph goes up to 27, and we went to 13. So that means there are, you're going to have to say 27 minus 13, and that'll give you 14 people. So sometimes when you get your answer here on the y-axis, sometimes that is the answer, but sometimes you're going to have to minus. I went and checked on the memo, and they did allow for between 12 and 14 as your final answer. They actually got an answer of 13 on the memo, okay? But that's fine, because they said that you're allowed to have an answer between 12 and 14. It all depends on how you draw the graph. So you're never going to get the exact answer to them, but luckily we do fit into the 12 to 14 range because we got 14, so that would be correct. But if you got 13 or 12, that's also correct. the first thing I want to mention is that these questions are going to carry on. Okay, so here's the first 3 questions, and then there's the next question over there. First question says, calculate the gradient of the line AC. Okay, so AC. Okay, so that's pretty basic. That's just your gradient formula, which is just m equals to, and then you can say y2 minus y1 over x2 minus x1. Now, I'm going to use this as my point number 2. This is my point number 1. And so now we just go fill it in. So it's 11 minus 3 over 10 minus. Now, this is also a minus, so I just say minus 2 like that. Then I go ahead and I just type it on my calculator. I don't try to figure any of it out myself. I just rely on my technology, and that gives me 2 out of 3. Or 2 over 3. So that's the answer for that one. Next question. Determine the equation of the line DE in the form. Okay, so DE. Great. So now we know that they do tell us in the statement in the beginning, and we can see it, that DE is parallel to... So these 2 lines are parallel, is what I'm trying to say. So let's just say here, let's just make some notes. So the gradient of... you can call it, I don't know, whatever you want to call it actually. You can call it GC or GA or GF. It doesn't matter as long as you call it this line. We can just say that the gradient of that line, so I'll just call it CG, or let's call it AC because that's what we used earlier, is the same as the gradient of ED. Why? Because they're parallel. You don't have to show them this in the test. I'm just making some notes for us. Okay, so they are parallel, right? So for the line DE, we can say y equals to mx plus c, but now we know its gradient. Its gradient will be 2 over 3, because that's what we worked out for the gradient of AC in the previous question. So we can just say y equals to 2 over 3x plus c. Now to find c on this line, you just substitute a point on this line. Can you see a point? I'm battling to find a point. Just joking, guys. We can obviously just use D. D's right there. So we plug in the y value as -1. We plug in the x value as a 5. And now we're just going to go ahead and solve. So we can, I'm going to take everything up here. So -1 equals to, now 2 over 3 multiplied by 5 is just 10 over 3. Then you can just take the 10 over 3 to the other side. And so you'd end up with -1 minus 10 over 3. Chuck it all on the calculator. And we get negative 13 over 3. So the equation of that line would be y equals to 2 over 3x minus 13 over 3. Aren't you guys just loving these fractions? I know I'm not. Next question, calculate the size of theta. Okay, so it's a little angle over there. It's in a pretty random place if you ask me. Oh, but guys, what I think we can do, remember, if we know gradients, if we know the gradient of a line, then we can work out its angle of inclination. Angle of inclination. And what do we use to do that? We use tan. Okay? So what I'm thinking, guys, if we look here, maybe you have a different way, but if we look at this triangle, okay, we know that this angle is the angle on the outside. So I don't know how familiar you guys are with the angle on the outside. Some learners don't like this method, but the angle on the outside of a triangle is always the same as the sum of the 2 angles. Not there. This is sum of the 2 opposite angles. Okay, so the exterior angle of a triangle, this is just notes. This isn't like something you would actually write for the examiner. The exterior angle of a triangle is always equal to the sum of the 2 opposite interior angles. Now, if you do not like using that, I know I didn't when I was back in grade 9, 10, 11, 12. I never used that. I did it in a bit of a longer way, and that was what some students like to do, and that is just to use angles on a straight line, and then you first find this angle, and then you can find that one using angles on a straight line. That is totally okay. There's nothing wrong with that. It gives you the exact same answer. Okay, but we're definitely going to be working in this triangle, okay? So what I'm thinking, guys, is the following. We know the gradient of this line, right? We worked that out earlier as 2 over 3. So because of that, we can work out its inclination angle, which would be this one over here. So all that we do is we just say tan -1 of 2 over 3, and that's going to give us angle G, so angle FGO. So that's this angle here. And so if you had to go work that out, you're going to get, so if you say shift tan on your calculator, shift tan 2 over 3, that's going to give you 33.69 degrees. Okay, so that's this angle over here. There we go. Now, this angle's 90. I mean, obviously, guys, it's the y and the x-axis, okay? So, if you are a student who is comfortable with exterior angle of a triangle, then you can just go ahead and plus these two numbers together, the 90 and the 33. If you are not a student who's comfortable, like the way I was back in high school, then you would first go work out this angle using sum of angles in a triangle, and then you would use angles on a straight line to find this one. That is okay. Takes a little bit longer, but it does give you the correct answer. Now, I'm just going to use the Foster exterior angle approach. So I'm going to say that alpha, is that an alpha? Yeah, alpha, or maybe we'll just call it A. It looks like an A. So A is going to be equal to 33.69 plus 90. Why? Because exterior angle of a triangle. And so if you work that out, you get 123.69 degrees. 123.69 degrees. Next part, B is a point in the first quadrant. Okay, so B is a point in the first quadrant. So the first quadrant is this one here. So B is somewhere there. Such that A, B, D, E, in that order, okay, forms a rectangle. So that's important that we do follow that order. So let's try figure out where B is. So A, then it goes to B, then it goes to D, and then to E. Okay. Now, if you're anything like me, like sometimes when you try fill this in, it just doesn't make any sense. Like, where the heck must B be for this to be a rectangle? Because if I put it there, oh, I see, something like that. Okay. So let's make it parallel. So let's make it parallel to this line. So it'll be somewhere along here. And it'll be the same length as this one. So let's go probably there. Oh, no, that doesn't make sense because then it looks weird. Okay, let's try some more. Okay, so we know that E is going to go to that. Oh, okay. And then D is going to go... Oh, there we go. Yeah, there we go. Okay, so B would be there. So A, B, D, E. A, B, D, E. Yeah, that works. So sometimes it takes me a bit of time, guys. Maybe I'm getting old. So, A, B, D, E. So B is a point to da-da-da-da-da. Okay, calculate the coordinates of M, which is the midpoint of BE. Calculate the coordinates of M, which is the midpoint of BE. Now, guys, we don't have to do that. We know that a rectangle, the midpoint is exactly the same whether you choose this diagonal or whether you choose this diagonal. This looks like a Gmail. See that? If you see it, let me know. That's a Gmail, like an email. Okay, Kevin, that's lame, dude. Okay, so once again, what I was trying to say before I got caught up by the whole Gmail thing was that when you want to find the midpoint of the diagonals, you can use any diagonal you want. It gives you the same midpoint. So they're telling us to find the midpoint of BE, but we can just laugh at them and be like, no, we'll just go find the midpoint of AD. Okay. So midpoint of AD is equal to y2. Sorry, what am I doing? I'm thinking of gradient formulas here. Okay, so x1 plus x2. You know the midpoint formula. x1 plus x2 over 2, and then y1 plus y2 over 2. And so I'm going to use this as my point number 1, and this is my point number 2. And so that's going to be minus 2 plus 5 over 2. And then, what's that, a 3? Yeah, it's a 3. 3 plus minus 1 over 2. And so if you had to go work this out, you're going to eventually end up with 3 over 2 and 2 over 2, which is 1. And so that is the answer. All right, now guys, some of you might be like, yeah, but Kevin, they asked us to find the midpoint of BE. Aren't we being a bit rude? Okay, yeah, guys, so technically we are being a bit rude. So we should acknowledge that we understand that the midpoints are the same. So we should say that the midpoint of, where was it? So the midpoint of AD is the same as the midpoint. I should have said this in the very beginning, actually, guys. The midpoint of BE. Why? Because these are the diagonals, so diags of a rectangle. Okay, it's like a property of the rectangle diagonals. It's also a property of parallelogram diagonals, rhombus, square, blah, 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 blah. Next question, calculate the length of the diagonal BE. Once again, okay, now this wouldn't be true if it was a parallelogram or a rhombus. If you had a parallelogram, then the diagonals are not the same length. I mean, look how long this one is. Look how long that is. Wow, that's long. And then look how short this one is. See, it's not as long. It's just from here to here. But look at this one. It's all the way from there to there. So it's a bit longer. So the parallelogram diagonals are not the same. But if you have a rectangle, I mean, these two diagonals are exactly the same. Okay? So we can just say that the length, so let's just say length of AD is the same as the length of BE. Why? Because of diags of a rectangle. Once again, it's one of their properties. Okay, so we can just go work out the length of AD. Now, to do that, we use the distance formula, which we'll quickly write down. Obviously, all of these formulas are on your formula sheet. Okay, and so I'll just use this as point number 2, and I'll use this as point number 1. Doesn't really matter. Okay, so we can just say that it is -2 minus 5, and then 3 minus 1. Okay, so just make sure you fill it all in correctly. So -2 minus 5, and then 3 minus 1. Then I go ahead, I don't even try to simplify it. I just go type it all in on the calculator. And it gives you the square root of 65. And then if you want to round that to 2 decimals, that would be 8.06. Whoops. Just want to quickly mention that these questions are going to carry on the next slide. So there's 4.1 and 4.2. There's 4.3 and 4.4. And then lastly, 4.5 and 4.6. Let's start. In the diagram, straight line. By the way, whoever designed this question, why did they have to make this so big? Jeez, it's like all the way down here. Hashtag when your teacher draws your diagrams according to scale. Okay, so I find that funny. So in the diagram, the straight line SP is drawn having S and P. What a noob teacher draws it according to scale. Okay, Kevin, get serious. In the diagram, the straight line SP is drawn having S and P, blah, 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 blah. The equation of SP is that. Okay, so that's actually quite important. The equation of SP has been given to us. Okay, so the equation of SP has been given to us. So x plus AY minus A equals to 0. Okay, x plus AY minus A equals to 0. A is positive. It is also given that, it's actually quite a lot of information in here that's not on the diagram. Usually it is on the diagram, so we need to watch out here. So OS is equal to 3 times OP. Okay, so that's important. Okay, I'm actually just going to highlight that's important and that's important. The straight line RT is drawn such that they're perpendicular. Okay, they showed us the perpendicular part. Okay, we've got that. RT cuts the y-axis there. Okay, so we've got that as well. Great. First question for 2 marks. Calculate the coordinates of P. Okay, so I'm having a bit of a crickets moment here, okay, can't really see what we should do here. I mean, if the answer is meant to have an A in it, then I could understand. Let's try that. So we know that this straight line is x plus AY. A's are always so dodgy, like it could be a 9. There we go, AY minus A equals to 0. Now, that's a straight line. Just forget about the fact that there's all those A's over there. If you normally wanted to find P, that would be the y-intercept. And to find a y-intercept, you make x 0. So let's just do that. Oh, it's going to work, guys. It's magic. Look at this. I can see it. Now try to get the y by itself. Then we can just divide by A on both sides. And so y is equal to 1. There we go. So the coordinates of P will be 0. Don't just say 1, say 0 and 1, because it's the x value is 0 and the y value is 1. The next question, for 2 marks, calculate the value of A. If you guys are finding these 2 questions quite weird, like overly challenging, then you're not alone. Like, I'm also looking at this and I'm like, okay, it's a bit different to normal questions, but I guess this is a good thing because you don't want to get it to an exam and see this type of stuff for the first time. So if you're feeling a bit weird, it's okay. I think most learners would actually feel a bit weird about these ones. Because like normally you would need a point that we could like substitute in, or, you know, just something. Oh, got it. Ha. So check this out, guys. This is quite important. So it says that the length of OS is 3 times the length of OP. But now OP's length, because we now know that P is 0 and 1, right? Remember, we just worked that out. So this length is 1. So that means that this length would be 3, because it's 3 times as long. So that means the coordinates of S will be 3 and 0, and that is a point that we could now substitute into this equation. Because we wouldn't use this point to substitute, because we've technically used that one already. So what we can now say is that, okay, so we know that x plus ay minus a is 0, so we can substitute 3 and 0, so 3 goes in the x's place, 0 goes in the y's place. So that's going to be 3 plus 0 minus a. There we go. So a is equal to, well, I don't want to confuse students. Let me take the a over to the right. So a is 3. There we go. Bam. Moving on to the next set of questions. It says 4.3 for 3 marks. Determine the equation of RT in the form y equals to mx plus c if it is given that a is 3. Okay, so why did they tell us that? Well, that is for people who maybe could not do question 4.2. So what I always tell learners is, guys, if you can't finish one of the questions, but then you look at the next question and it gives you the value of a, then just use that value of a and just carry on. Don't just go to the next question or like walk out the exam room and like throw your calculator at the teacher, or, you know, like just chill and then just be like, okay, cool. This value of a has been given, and then we can use that, and then we can carry on. All right. Because I know I've had some learners. I'm not a teacher at a school, by the way. I've mentioned this in some videos. I'm just people like come to my office, or these days I teach from home, so people come to my house and I teach them. And I've had some learners in the past, and if they can't get like the first question right, they just like, nah, so I'm done. I'm going on to the next question. I'm not doing this one. And they get really negative and really upset. But don't be like that, guys. Just, if you get 4.1 and 4.2 incorrect, but then they tell you, oh, A is 3. I know it feels a bit discouraging, but just try to just carry on and then just try 4.3. Maybe 4.3 won't be as bad as 4.1 or 4.2. Okay, Kevin, talking too much, dude. Let's get back to the maths. Okay, so 4.3, so it says determine the equation of RT in the form y equals to mx plus c. Okay, so we know that RT is a straight line, right? So y equals to mx plus c. Now, what you should identify is that this line and this line, they are perpendicular. Now remember, when two lines are perpendicular, it means that when you multiply their gradients together, so the gradient of PS multiplied by the gradient of RT, it should always give you a value of -1. And that is when two lines are perpendicular. Remember that, guys. That is like a mathematical rule when two lines are perpendicular or meeting at 90 degrees. So, okay, so we can definitely get the gradient of PS. You can do that in two ways. You could work out the gradient using these 2 points, which we found, or you can just take the equation of the line PS and just rearrange it so that it looks like a straight line. So we know that the value of A was 3. So then, see what I did? I just plugged in the value of A into this equation, and now we can just get the y by itself. So we do that by dividing everything by 3. 3 divided by 3 is 1. Okay, so that is the equation of PS. So that means that the gradient of that line is -1/3. Okay, because that's always the gradient, the one that's in front of the x. So we can say, therefore, the gradient of PS is -1/3. So then what we can do is we can take this equation. Let's just write it down here again. So the gradient of PS is -1/3. I feel like I've said that 100 times. And the gradient of RT is -1. And then if you had to go work out, by the way, did you know the gradient of PS is -1/3? Okay, so the gradient of RT would then be -1 divided by that. And so if you had to work that out, okay, we don't need the dots, Kevin. So we can say that the gradient of RT is 3. Fantastic. So the gradient of RT is 3. So now we have that is, the gradient is there, is 3. Then to find c, you just need any point on this line, because that's the line we're looking for. So we could just take this point over here. So I don't like working with mixed numbers. I've got mixed feelings about that. Haha. So if we convert that into an improper, you don't have to, but I want to for myself. So 5 times 2 is 15, plus 2 is 17, so it's minus 17 over 3. Okay, so minus 17, I'm feeling really claustrophobic working in this little corner here. I might need to move us out of this corner soon. So minus 17 over 3 equals to 3, and the x value there is 0, plus c. Okay, so if you had to work out c, you're going to get negative 17 over 3. So therefore, the final answer here would be y equals to 3x minus 17 over 3. Okay, this question over here. Calculate the coordinates of R, the point where PS and TR intersect. Okay, so we're looking for the point R where two lines intersect. Now we know, because we're experts, that when where two lines intersect, the way that you find that place is you just make their equations equal to each other, right? So, okay, so I forgot what we wrote this one down as just now, but let's just quickly rearrange it. Okay, so that equation for PS was that over there. Okay, I remember now. So that's PS's equation. That's PS's equation. Oh, that was lame. Okay, so and then the equation for RT is the equation for RT we found in the previous question as that. So then we're just going to make them equal to each other. So we're going to make these two equal to each other. Okay? So we're going to say minus a third x plus 1 equals to 3x minus 17 over 3. And now you can do this in so many different ways. Yeah, there really are so many ways. You can get a common denominator of 3 if you want. Or I think what I'm going to do is I'm just going to bring this over to the right-hand side. And then I'll just take this over to the left-hand side. I mean, we're in grade 11 now, so like if this was grade 10 and 9, I would like tell them, guys, you have to get a common denominator. But in grade 11, I think most of us, we're okay. So we take this, and I'm going to move this one over to this side, so you would end up with that on the right-hand side. And then on the left, you would end up with that over there. Okay, so then I'm just going to type both of these in on the calculator. Okay, so if you type this left-hand side on the calculator, you end up with 20 over 3. And then if you type the right-hand side on the calculator, you end up with 10 over 3x. Okay, now you can do this in as many different ways as you want, but the way I would do it is I'd realize, okay, there's a 3 on both sides, so I'll just ignore that. But I know some of you would be like, I'm not comfortable with that, so then you can do it in a different way, okay? So I'm just going to get rid of the 3's. There we go. Get x by itself. So x is 2. But they want the coordinates. So that means we need the y value as well. So we will need to plug this x value into either the equation of PS or the equation of TR. I'm just going to use TR because we have it over here. So to get the y value, we just plug in the x value as 2. And so if you had to work that out, you end up with a third. So y is a third. So the final answer for R would be x is 2, y is a third. Okay, last questions. Calculate the area of the triangle PRT if it is given that R is that. Ha! So they gave us R, and that's what we got, so we can be 99% sure in a test that we were correct. It's pretty awkward if we didn't get that. I've had that feeling before as a student, and then you sit there and you're like, oh no. I mean, either you're very confident as a student or you're not. So like if you're a confident student, and the value that you got for R is not the same as this one, well, then you'll just be like, oh, okay, that's interesting. They just wanted to obviously change it up. But if you're a student who's not very confident, and then you see that the value that they're using here is not the same as you got, then it's like, okay, well, this test is just going great, isn't it? Okay, so calculate the area of triangle PRT if it is given that. Okay, so here's the triangle PRT. So this is pretty easy. A triangle's equation is just the half base times height. Now students, even in grade 12, are still struggling with this whole base height thing. The base height are the two that make 90 degrees. Okay, so that means it's this one and this one. Okay, you are not going to use this one. And it doesn't matter which one's the base and which one's the height. You can use this as the base and you can use this as the height. Or you could use this as the base and this is the height. That doesn't matter. I wish they drilled this into us in like grade 8 and 9. It doesn't matter. So we are definitely going to have to go and quickly get the distance of this one, and we're going to have to go get the distance of this one. It's pretty annoying when we have to go get the distance formula twice. It's like, ugh, it takes forever. Okay, but let's quickly do it. No use complaining, eh? So, I got to share a quick story. So, where I live, okay, it's in like a gated community kind of place. So we have a security, like at the front gate where you come in, and this guy's always like, you know, you get those people where whenever you say hello to them, they always say the same thing, like, hello, how are you, good, and you. It's like the same thing, but they do it every single time. So with this guy, whenever I see him, I always say, hey man, how's it going? He's like, I'm good, brah, it's no use complaining. Why? Because no one's listening anyways. But he says this every single time. So, yeah, shame. Maybe I should ask him to go for a coffee or a beer someday and maybe be the guy who actually listens to him. Maybe he's got some deep stories he needs to... Maybe he's got some interesting stories that he needs to share, but everyone just keeps saying, hey, how are you doing? Good, and you? Bye. Yo, I'm talking a lot of nonsense in this lesson. Okay, so let's move on to more interesting things, such as calculating the area of a triangle. So we need to go find the length of PR. But yeah, it's just funny because he says that every single time. There's no use complaining, bruh. No one's listening anyways. But it's actually quite hectic if you think about it. Like, sometimes I'm like, wow, that's actually deep. Yeah, maybe I'm the one that's wrong. I just drive past in my car and I'm like, okay, bye. But maybe I should, yeah, maybe I'll go clubbing with him one day. I'll ask the security guard at the gate if he wants to go clubbing with me. Hey, but I don't actually club that much. Maybe I'll go play... No, I don't do golf either. Quite a boring guy. Maybe I'll just take him for a coffee or something like that. Okay, so to calculate the length of PR, we are going to do the distance formula. Okay, so x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to use, you guys know how to do this, right? So I'm just going to quickly race through this. I'm going to use that as point number 2, that as point number 1, and I'm just going to go 1, wrong one. So 0 minus 2 squared plus 1 minus a third squared. Go ahead, type it all on the calculator. No need to simplify any further. Calculator does it all for you. Okay, I'm going to leave it as a surd or a square root. Who uses the word surd these days? So we're going to do that, a square root, 2 square root 10 over 3, just because if I round off, it's going to affect my answers. And I know how these people set up these questions. If you round it off, it's going to give you an ugly answer later on. It's going to be like some decimal. But if you leave it like this, it usually gives you a beautiful answer. You type it in and it's like 10. So it's nice. Okay, so that's PR. Boom. Now we need to go get the length of RT. So it's the same thing, copy paste. So let's use this as point number 1 and this is point number 2. So distance formula once again. Okay, so I'm just going to go type in. So 0 minus 2. I'm going to change this to a improper once again, like I did earlier. Minus 17 over 3 minus a third squared. Type in. Okay, so 2 square root 10. Okay, there we go. Look at this. It's beautiful. Okay, so now we can go use the area formula. So we know that area is a half base. Now, it doesn't really matter which one you use. And then the other one. There we go. Go ahead, type that all in at once. And that gives you 20. Okay, it wasn't too bad, hey? 20 over 3, but we should round that off to 6,67. And then before some of you have an absolute heart attack, I've seen it before, how some of you get really nervous about this. Yes, guys, we can say square units because we're busy with area. I get a lot of comments from students who are like, sir, shouldn't we say meter squared or square units? Yes, we should. That is correct. Okay, then the last one. Calculate, giving reasons, the radius of a circle passing through the points P, R, and T. Okay, so if there was a circle going through P, R, and T, okay, so it would look something like that, okay? Don't laugh. Now, what they always like to do, guys, you know from grade 11 Euclidean geometry, whenever you have a diameter, then whatever angle that one makes on the circumference is always 90 degrees, right? That is like the angles in a semicircle theorem. So this is what they're trying to do. They're trying to get you to realize that that's the 90 degree, so it means that this is the diameter, okay? That is the diameter. So, okay, that is the most important step. This is the diameter. So if you then want to get the radius, which is half the diameter, you just need to work out this distance and then just divide it by 2. Now you don't have to go use the distance formula. Why? Because this line is vertical. So if that's 1 unit and that's 5 2/3, then to get the length of PT, you can just say 1 plus 5 2/3, and that's going to give us 6 2/3. But now that's the diameter of that circle. So if you want the radius, you must just divide that by 2. So the radius is going to be 6 2/3 divided by 2. Now be careful when you type this number in. This is why I don't like using mixed numbers on a Casio calculator, because if you don't type this in using the shift method, it actually does something completely different and it ends up multiplying over here. Maybe that's happened to you before. So I actually advise that we always change this to an improper. 6 times 3 is 18 plus 2 is 20. And then just make, and then even this sometimes goes a bit dodgy. Some students, they type it in like this. See the problem there? The 20 is by itself, and then the 3/2 is the fraction, but it's supposed to be like that. So how do we fix that? Well, what I then tell students to do is rather just type it like this on your calculator. Okay, all these stupid little tricks that we have, but it helps. And so the final answer should be 10/3. Just a quick note, these questions are going to carry on. So we've got 5.1.1, 5.1.2, and then on the next slide, 5.1.3. So let's start. Let's first see what we have here. In the diagram below, P, okay, that is a point such that OP is 25, blah, 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 where B is an obtuse angle. Calculate the value of X. Okay, guys, so what we do is we just make a triangle. That's step 1. Even though the angle's on the outside, you're just going to work from this little angle on the inside. You are never going to try work out this angle and say, oh, that's 180 minus beta because of angles on a straight line. We don't do that. You're just going to work from this angle. Okay, so we know that this length here is 25. This length here. This is a y value, so that means that this length is 24. And so you need to work out this distance over here, because then that will help you to work out the value of X. So to do that, we just use Pythagoras. So we can just say that 25 squared is equal to, let's just call this X squared plus 24 squared, and that's because of Pythagoras. And then if we had to get X squared alone, you would eventually get 25 squared minus 24 squared. Okay, and that's going to be 49, but then if you square root that, you're going to get 7. Now, be careful. This length is 7, but because it's going in the negative direction, this X value here would actually be negative 7, right? Because it's in the negative, it's where X is negative. So the value of X is negative 7. So I'm just going to put in a negative 7 over there, just so we can remember that. Next, determine the value of the following without using a calculator, sin B. Now, remember, B is there, but guys, you're just going to work from this angle over here, and you're just going to use sin. Now, sin, depending on if you use the XYR method, or if you use something like SOHCAHTOA, or any other little riddle that your teacher's given you, like some old hens cackle and how, you know, all these weird things, or oh, how another hour of algebra. I've heard so many different ones, but the most famous one is just SOHCAHTOA. And then some learners still prefer to use the YRX method. Okay, so sin is equal to opposite over hypotenuse. If you prefer the YR method, then it's Y over R. Okay, so if we're starting here, then the opposite is 24. And the hypotenuse is the 25. Okay. Now some learners are like, okay. They say sin beta is 24 over 25. And then they start saying shift sin on their calculator, and they want to start working out, they want to start going further by using shift sin. But remember, if you use shift sin, then you are calculating the angle beta. But they didn't ask you for the angle beta, they're asking you for sin beta. And look, we have it, sin beta is equal to 24 over 25. If the question said, find beta, yeah, then we can start looking for angles and stuff. Okay, that catches a lot of students out. Next one, cos 180 minus beta. Okay, so we need to use our cast diagram first. Okay, so we know that this is always 180 minus beta, this is always 180 plus beta, and this is always 360 minus beta. Now, okay, so we have 180 minus beta, so we've got that, but cos is negative in that quadrant. Remember, this is the quadrant where sin is positive, so this is going to end up becoming, I hope your reduction is pretty good, so you understand what I'm about to do. This just becomes negative cos beta. If you're confused right now, you need to go back and go over your reduction. Okay, so that's just going to be negative cos beta. Now we need to go get that on this diagram. And then we'll need to go get cos beta, which is from the SOHCAHTOA. We know that cos is adjacent over hypotenuse. If you prefer the XRY method, then it'll be x over r, sorry. And so that's going to be negative, because we have a negative over there. And then x is negative 7, so we'll put a negative 7. And then r is, not r, but your hypotenuse is 25. And so those negatives are going to cancel, or they're going to combine to make a positive. And so the answer there would be 7 over 25. All right, and then the last one for this one, please note there are still more questions that follow on, but for this slide, tan negative beta. Okay, so on our cast diagram, we know that we have 180 minus beta, 180 plus beta, and 360 minus beta. What I've said in previous lessons is that if this angle does not look like anything on this cast diagram, just add 360 or minus 360 depending on what is appropriate for that particular scenario. So for this one, what we're going to do is we are going to add 360. We are allowed to do that because mathematically, if you are on a cast diagram over here, if you add 360, you're in the same place. And if you minus 360, you're still in the same place, okay? Now, the reason we do that is when you plus, order doesn't matter. For example, 3 plus 5 is 8, right? But 5 plus 3 is also 8. So when you plus, the order doesn't matter. So now I can put the 360 in the front, and I can put the minus b over there. So that becomes tan of 360 minus b. And now we're happy because we have something that is on our cast diagram. So we know that tan is not positive in this quadrant. Tan is negative, so this will just become negative tan b. Now we simply go to our diagram and we get tan. Now tan from SOHCAHTOA is opposite over adjacent, but if you prefer the XYR method, then it's y over x. And so we go to our little diagram and we look for the opposite, which is 24, and we look for the adjacent, which is negative 7. So this is going to become negative, and then the opposite is 24, and that's negative 7. So these negatives are going to cancel, and so your final answer there should be 24 over 7. And here's the last part. So it says that T is a point on OP. Okay, so there's T, we can see it. It's a point on the line OP, yep, such that OT is 15. Okay, so this is only 15. Determine the coordinates of T without using a calculator. Okay, so bit of a weird question, but anyways, we already worked out earlier that x was minus 7, right? So this length here, they tell us, is 15. So how far up this line have we gone? Or what fraction of this line? So we can say that, so like what fraction of this whole line is OT? Well, we can say that OT is 15 out of a total length of 25, right? And if you simplify that, that's 3/5. So that means that the length of OT is 3/5 the length of OP. Okay, so it's 3/5 the length. So then we can just take the x value and get 3/5 of that, and then we can take this this y value, and just get 3/5 of that. So the tx value, or let's rather say the x value of t will be 3/5 of this x value, which is times by minus 7, and so that's going to be negative 21/5. And then the y value of t will be 3/5 of this one's y value, which is 24. And so that's going to be 72/5. And so the final coordinates, or the way that you'd write the answer, would be the x value, negative 21/5, and then the y value, 72/5. Determine the value of the following expression. Okay, so we need to simplify this thing as much as possible, but everything is simplified. Like, there's no reduction that needs to take place. So what I would do is I would just multiply to get rid of the brackets. So I need to take this entire term here and multiply it into the bracket over there and over there. Okay, so that would give us 2 sin x cos x for the first part, because you're just multiplying it by 1. Then you're going to say plus 2 sin x cos x tan squared x. What some learners would have done is they would have multiplied the 2 and then the sin x and then the cos x, and they would have gotten a weird answer like 2 tan squared x, sin tan squared x, and then cos tan squared x. But remember, guys, this is one term, so you're just multiplying it in the front like that, okay? And then at the bottom, we have tan x. Now, there's many different ways you could go from here. You could divide both of these terms by tan x. So you could, like in grade 8 and 9 where you would do something like that. Yeah, I think let's do that just for the fun of it. There are other ways. You could have changed this into sin squared over cos squared. But let's just do what I suggested. Well, I mean, you don't have to do that, but that's what I'm going to do. So 2 sin x cos x over tan x plus 2 sin x cos x tan squared x over tan x. So I just split them up, okay? Now, if you look here, these tan square, or these tans can cancel, not completely, but this tan can cancel with one of these tans. So you would end up having, you'd cancel out that one, and you'd end up having 1 tan x at the top here. Okay, so that's what we'd have over there now. Right, then what I would do is I would change this tan x into sin over cos. So I should actually be doing this on the other next lines. I'm going to change this one to sin over cos as well. So sin over cos like that. And then I'm going to do the same over here. Okay, now if you look here, you've got a cos at the top and a cos at the bottom. So those can cancel. So those can cancel out because you've got one at the top, one at the bottom. Now, some learners do struggle with what to do here. So what happens is that this cos x is actually going to end up going to the top, and then this sin x will just stay here at the bottom. Okay, you might have your own way of doing that. You might have to just pause and think about that for a bit. So that's going to end up giving us 2 sin x cos x times cos x, and then at the bottom you're still going to have the sin x. All right, and then over here we're still left with 2 sin x times sin x. Okay, now where a lot of learners make mistakes over here is what they do is they say, okay, so we have 2 sin x's and at the bottom we have 1 sin x. So if we cancel them, then there'll only be 1 left over. But that is not correct. This 2 has nothing to do with that sin x. So what we're going to do is you're going to cancel that sin x and you're going to cancel that sin x. Okay? And so what we end up having with this whole thing is you've still got a 2, and then you've got a cos x and a cos x left over, so that's going to become a cos squared x. And then over here we've got a 2 sin squared x. There we go. You can take out a 2 as a common factor, and you're left with cos squared x plus sin squared x, which is 1. Remember, this is the identity. We usually say sin squared plus cos squared, but it doesn't matter if you have cos squared plus sin squared. So that's going to be equal to 1. And so, sorry guys, I'm going to move the answer up to the top here. And so we're going to end up with 2 multiplied by 1. And so the final answer for this entire expression is just 2. Okay? consider the expression, and then it says for 3 marks, so it won't be too bad, simplify this expression to a single trigonometric term. Okay, so if we look at the top, if you look at that entire expression, we know that sin squared x plus cos squared x is equal to 1. So if you had to move this over to the other side, you would have 1 minus cos squared x equals to sin squared x. So you see what we have here is 1 minus cos squared x, and here we also have 1 minus cos squared x. So what we can see then is that this 1 minus cos squared x, we can replace it with sin squared x. So we can replace this with sin squared x, and so that's going to be equal to sin squared x at the top. Then at the bottom, we have a cofunction. Now remember, there are 4 cofunctions that we need to know. So they all become the opposite. So this one just becomes cos x. This one becomes cos x as well. This one becomes sin x. And then this one's the weird one. This one becomes negative sin x. This cos 90 plus, that one becomes negative. And that's actually the one that they gave us here, the sneaky people. So what we need to do is change this into negative sin x. Because you see we have it there, and we have it there. Okay. So we're going to change it to negative sin x, like that. And so we end up having sin squared x over negative 4 sin x. And so what happens now is that you can cancel out one of these sins, okay? So you can cancel out this sin over here with one of the sins at the top. And so we would end up having 1 sin x left over at the top, and then at the bottom, you're just going to end up having negative 4. So if you want to write this in a better way, you can just say negative sin x, or you could say negative, you can just put the negative in the front, so negative sin x over 4. You could also write it as negative 1/4 sin x if you wanted to, okay? But I think what I'm going to do is I'm just going to leave it like that. Okay, and I realized that all throughout this video I've been using x instead of a. Please don't shoot me. I mean, that was just a small mistake. It's not that serious, hey guys? Okay, so let's just write down our answer here. We said negative sin x over 4. The next question says, hence, determine the general solution of this. Okay, so what you guys need to do is you need to try see the pattern between these two things. Between this one and between that one. So let's have a look at those carefully. So here they're using an A and an A. Here they're just using a 2x and a 2x. But besides that, everything is exactly the same, right? So we learnt in the previous question that 1 minus cos squared A over 4 cos 90 plus A. We learnt in the previous question that that becomes minus sin. Now, I'll change it to a. Sorry, I did apologize, but I was using x's the whole time. We know that that turns into that. So then what they want us to do is to think about what would this become then? Well, you can just follow what we did here, but you don't have to go do everything because they said hence. So we're using the previous answer. So then we can say that 1 minus cos squared of 2x over 4 cos 90 plus 2x, we can then change that to minus sin. Now you just copy the angle. So if this was a and this one's a, now this one's 2x, so then this one also becomes 2x over 4. Okay, so that's what we can change this part into. So we can rewrite this equation now as minus sin 2x over 4 equals to 0,21. And now this just becomes a whole brand new general solution question. So what we need to do is we need to try to get this sin 2x by itself. So what I would do first, I'll take this 4 and I'll multiply it across. So that's going to end up giving us negative sin 2x equals to 0,84. Okay, then this negative, we can divide by that negative. So it becomes sin 2x equals to negative 0,84. Okay, so I'm going to start over here now, or carry on over here, should I say. Right, now this becomes a fairly basic question. So what we need to do now is get the reference angle, but you don't put the negative on the calculator, guys. So you're just going to say shift, for those of you using a Casio, which is most of you, you're going to say shift sin of 0.84, just to get our reference angle. And so the reference angle will be 57.14. Now I'm not going to round off. Okay, I won't round off until the end. So that's that. Now, the negative, you might be wondering, okay, well, what does the negative do? Well, the negative tells us that we are in the quadrants where sin is negative. So if we think about our cast diagram, where is sin negative? Sin is negative in the third quadrant. This is the third quadrant, and in the fourth quadrant. So we are going to go work in the third quadrant and the fourth quadrant. So in the third, okay, so now what we do is we say whatever this angle was, so that's 2x. So we say 2x equals, now in the third quadrant, we always say 180 plus. Okay, I'll carry on with that now. I just want to show you guys that it's actually just a pattern. In the fourth quadrant, it's 360 minus. That's what we say. Now, over here, we put the reference angle that we calculated, which is the 57.14 value. Okay, and I'm going to put it over here as well. And then, of course, we have to remember that boring old part, plus k 360, k is an element of z. You might use a different letter. You might use the letter n. A lot of schools do that as well. That's absolutely fine. They really don't care about that in the exam. K is an element of z. Okay, now we just need to go get x alone. So we're going to get, okay, so I'm going to do it all in one step just to save space. But you're going to add these two numbers together. Okay, and then you're also going to have to divide everything. Okay, well, let me show you that part. So 2x is going to be equal to 237.14011196 plus k360. K is an element of z. Then to get x alone, you're just going to divide everything by 2. Okay, so you're just going to divide that one by 2. And so you're going to end up getting 118.57 plus k times 180. So it's important that you also divide this one by 2. Okay, so you divide that one by 2, and then k is an element of z. And then we're going to go do the same process for this one over here now. And so if you had to put those two numbers together, you're going to get 302.8598804 plus k360. K is an element of z. And now we're just going to go divide everything by 2. And so now we can round off to 2 decimal places. So that's 151.43 plus k times 180. K is an element of z. In the diagram, the graph of f of x equals to tan bx is drawn. Okay, so we've got tan bx. The first question for 1 mark only says determine the value of b. Right, now b is over there, okay? Now if you've watched the other lessons where I talk about the different letters or the different parameters and what they do to the graph, then I want you to just realize that sometimes they won't use the same letters, okay? Sometimes they'll use random letters, but what you should realize is that this b is the equivalent of this k. So can you remember what or how to work out the value of that k? Or what you can do is you can just say k, or in our case, sorry, we'll say b, and you're going to use a formula that goes original divided by new. So what do I mean by that? Well, I want you to find a point on this graph, let's say, for example, the 45 degrees. So that would be the new, because this is the new graph, and I want you to think about what that point would be on the original tan graph. What is an original tan graph? I'm literally talking about y equals to tan x. So we know that a tan graph starts at 0, okay? But where, think about this carefully, where does a tan graph normally have its asymptote, the first asymptote? It's at 90 degrees, right? So you're just going to put a 90 over there, and that's going to give you 2. Could I only have used that point? No, I could have used any of the points. I could have even used this one. So if I used that one, I would have said that that's the new value. And, sorry, that's 90, Kevin, 90. On the original tan graph, though, if you know your tan graph quite well, you'll know that it starts at 0, and then it goes through 0 at 180 degrees the next time. And so if you had to work that out, that also gives you 2. Okay, so the value of b is 2. Next one. Determine the values of x for which the graph f of x is smaller or equal to -1. Okay, so what we're going to do is we're going to go to -1. And I'm going to highlight the entire -1. So they literally just want to know, where is the graph smaller than -1? So that means this area here. But be careful. They told us that they only want us to look between 0 and 135. So we're not going to look at this area here. They told us to leave that part out. So only looking in this area here now, where is the graph less than -1? Well, it's here. Can you see it? It's that. Let me actually get a highlighter. It's this area here. Okay, so what we do is we give the x values. So that'll be between the asymptote, which is the dotted line, which is at 45 degrees, and it goes up to this point over here, which would be halfway between 45 and 90, which is 67.5 degrees. 67.5. So it's going to be between 45, so we can say x is bigger than 45, and then smaller than or equal to 67.5. The reason I said that this one can be equal to is because that's what they asked us to do. And then the reason I didn't say for this one is because that 45 is the asymptote, and you can never, ever, 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 ever include the asymptote, okay? So you don't ever include the asymptote, and so that's it. Now, if you prefer interval notation, you would have said it like this. Round bracket, and then square bracket for 67.5. Let me write that a bit better. 67.5 with a square bracket. Next one, graph H is defined as, okay, so we've currently got graph F. Now they're talking about another graph, H, which is defined as tan of B. Okay, so this one's also tan of B. And then it's got x plus 55. So they're saying that h of x, let me just write this out again, is tan x plus 55. Oh, there's a b as well. Okay, now graph F, which is the original one, was also tan b of x. Tan b of x. So what have they done? Well, they're trying to tell us here that graph H is the same as graph F, but then they do this to it. Now, what does that do to a graph? Well done if you remember that moves the graph 55 degrees left, not right. I know a lot of you are like, yeah, but it says plus. But remember, guys, when it's the x values and graphs, it's always the opposite. Okay, so what we can say is that graph H, this isn't what you'd say in the exam. I'm just giving you guys some notes. H of x is graph F. Wait, h of x is, let's say, is the graph of f moved 55 degrees to the left. Okay, so it says write down the equations of the asymptotes of h in this interval -90 to 135. Okay, so if we look at these asymptotes that we currently have, those are all going to move 55 degrees to the left. Okay, they're all going to go 55 degrees to the left because the entire graph is going 55 degrees to the left. So if you move this one 55 degrees to the left, that would go to -100. So we won't include that one because it's it's outside of the interval. So we won't include that one. If we look at this one and you move it 55 degrees to the left, then it would be at -10. So you can say x equals to -10. And then if you had to move this one 55 degrees to the left, it would be at 80. Okay, now what we just got to quickly check out for is we do know that there would have been another asymptote for this graph. So if we look at the distance here between these graphs, this distance is, 90 degrees. So if you had to add on 90 over here, that would be 225. And if you had to then move that 55 degrees to the left, so you'd say 225 minus 55, it'll be too big. I think you'll get 170, which is too big for this number anyways. Okay, so the only answers for this question will be x equals to -10 and x equals to 80. Just want to let you know that these questions do carry on. So this is 6.2.1, then you've got 6.2.2, 6.2.3, 6.2.4, and lastly 6.2.5.
First question, 4 marks. On the same system of axes, draw. Okay, guys, when you are asked to draw, smile because it's easy. We're just going to use the calculator for that. It does not get any more difficult. So draw the graph of k of x, which is equal to that, over the interval of minus 150 to 120. Show all the intercepts with the axes as well as the coordinates of the turning points and end points. Okay, so they want us to show intercepts with axes, turning points, and end points. Okay, so we must include that. So let's get our calculators out. So what you're going to do is you're going to put your calculator into table mode. So for me, that's number 7, but it might be something different for you. Then you're going to type in your equation here, which is minus sin x. So minus sin x like that. Okay, push equals. The g of x is any other graph that we have. We only want to draw one graph. The starting position is going to be at minus 150 because that's where the graph starts. The ending position is going to be at 120. So you can just do that. Now the step is an important one. Your step is always going to be equal to your period of your graph divided by 4. Now, this is a normal sin graph, right? Obviously, it's been flipped upside down, but it's a normal sin graph. So a normal sin graph, where there's no like random weird numbers there or anything like that, has a period of 360, right? So if you divide that by 4, you get 90. So we are just going to use a basic standard step of 90 for this graph. So we just enter 90, and there we go. There probably, or maybe there'll be a few points. Okay, let's have a look. Okay, so it's just a few little points. I'm going to quickly go ahead and write those down. So I've written those points down, and now we're just going to go plot them. So minus 150 and 0.5. So minus 150 and 0.5 is this one. Okay, so it's going to be there. Then minus 60 and 0.866. So minus 60 and 0.866 would be somewhere over there. And then 30 and minus a half. There we go. And then 120 and minus 0.866. Okay, now that we're not done, because we've got the end points. We've got the ending points, which is this one. So let's quickly show those coordinates because they asked us to show the coordinates of that. So this one would be 120 and negative 0.87 to 2 decimal places. And here's the other end point. So that would be negative 150 and 0.87 over there. Now, this is not the turning point, by the way. That's just a random point. I mean, it could be something like that, okay? So, okay, I didn't do that very nicely, but it might be something like that or whatever. So we don't have the turning points. All that we've actually found is the ending points. So what do? The calculator can't help us here, so I'll show you what to do. Here's where you got to understand your graphs fairly well. So we know that this is a sin graph. Okay, now a normal sin graph just looks like that, right? Where this would be 90, 180, 270, 360. But then the minus, all that does is it just flips the graph upside down. So everything just goes in the opposite direction. So it does that. I will erase the red one now, so it will be a bit clearer. Okay, so oops, let's just do that. Okay, now let's take the red one away. Right, so this would be 90, 180, 270, 360, and then negative 90, negative 180. Okay, so, okay, I was wrong. The turning point wasn't there. Okay, so we know that there's a turning point at negative 90, so we can just go put that in. Now, you just got to see what negative 90 would be. That would be 90, that would be 120. Okay, so it's negative 90, and on normal sin graph, this is a 1, right? This is a 1. This is a minus 1, and yeah, that's it. Okay, so we've got that turning point, which is great. Then we got another one here at 90 and minus 1, so let's go fill that in. So 60, 90, that would be here. Oh, I should be using red. And so let's just give the coordinates. So minus 90 and 1, 90 and 1. And I think that's about it. Oh, and then we have to also do the intercepts. Okay, so we're definitely going to have that intercept, which is just 0, 0. So 0, 0. Would there be any other intercepts that we would actually get? No, because all the others are outside of the interval. So that's about it. So we can just try to connect these as neatly as possible. So like that. All right. Next one, determine the minimum value of h of x. Okay, so this is just a random graph. It's not any of the graphs that we have. Okay. So it's a cos graph. So it's a random cos graph. So, well, let's explain. So a normal cos graph, right? A normal cos graph, we know, starts at... Okay, I'm not going to worry too much about this part. I'm just going to worry about the right-hand side. So it usually does something like that. It starts at 1, goes down to -1. Great. What does this do? What does this do to a graph? Well done if you realize that that just moves the graph 60 degrees to the left. So I'm not even going to do that. You'll see why just now. It's not going to make a difference to the answer. So it would move the graph to the left. Okay. And then what does this do to a graph? That moves the graph 3 places down. So all of these would move 3 places down. Okay. So then what would the lowest value be on the graph? Well, it would obviously be this one after it's moved 3 places down. So that would mean that it would go down to -4. And so that is the answer, -4. The next question for 6 marks. Solve the equation. Okay, so this is just the general solution. Now I've made loads of videos on all the different types of general solution that we get. And this actually fits into the very last type. Okay, so I've showed you all these different types, and this is the last type where you have to use cofunctions. Okay, so this is a cofunction general solution. It's the type that they usually show you in class last. Okay, it's the last one that they show you. All right, so the way it works is the following. So you want to get the cos on the one side and the sin on the other side. So we can say, it doesn't really matter, but I'm going to keep the cos on the left. Actually, I don't want to run out of space. So let me do it nicely. Let's erase that. And then let's do it here, because I always tend to run out of space. Okay, like that. Now, some students often say, okay, well, Kevin, can't we just like divide by cos and get tan? That works whenever it's the same. So like sin x and cos x. Or maybe you have, sin x equals to cos x, or sin of 3a equals to cos of 3a. So when these are the same, then the tan approach does work. But when these are different, then you cannot use the tan approach. Okay, so we're definitely going to use the cofunction approach. So what I like to normally do, just to make it an easy method to remember, is I always just look at the one that's on the right-hand side. Okay, whether it's sin or cos, doesn't really matter. And we switch that one. So what does sin x become? Well, we know that sin x can change into cos 90. Wait, let's get this right. Sorry, cos of 90 minus x. We'll just use that cofunction over there. Although, I'm actually thinking, we've actually got a few options here. Doesn't really matter. This is the beauty of maths. We also know that, well, let's go write down all of our cofunctions quickly. We know that there's this one. Okay, so that's the one I've just used. And then, so these are the 4 different cofunctions. Then you also get the sin 90 one, which is cos. And then cos 90 plus, that's negative sin. Maybe we could use that one. That would be interesting. And then this one, the next one is, sin 90 plus, that's cos. Okay, so maybe what I was thinking is, we've got this and that. So what we could then do is just change it for that one over there. So that's going to be cos x plus 60 equals, then I'm just going to change this to cos 90 plus x. Okay, that's step 1. Then there would have been another video lesson that I showed you guys before the cofunction video, where I show you what happens if you have cos and cos on both sides, or if you have sin and sin on both sides. What we saw in that lesson was that when you have the same on both sides, you just cancel them out like that. And then you can just say x plus 60 equals to 90 plus x, and then stop. Many learners, they're like, oh, okay, cool, we're just going to go solve this now. No, you don't. You're going to stop right there. Now, what we do, you know how we normally have like general solution questions where we've got like sin of x minus 10 equals to 0, 4, okay? imagine that was the question. What would you do next? Well, you would normally go get a reference angle, and you would say shift sin of 0,4, and that would give you, this is just an example, I'm just showing you guys something quickly. And so you would normally get your reference angle as 23 point, it would be about 23.578. Okay, and then what you would do is you would use this one, and then you would use the reference angle, and then you would go to the quadrants. Yeah. So what we do now is we use this one as, let me show you guys something with a highlighter. We'll use this part as that part, okay? And then we'll use this one as the reference angle. Because if we're to carry on over here, you would then go work in quadrant number 1, and you would go work in quadrant number 2, and you would start off by saying x minus 10 equals, and then x minus 10 equals, and then for quadrant 1, you would just put the reference angle, so you would put the 23.58, but then for quadrant 2, you would say 180 minus, and then you would put your reference angle. Okay, this is just an example. So now you're just going to do the same thing. So this becomes the part in the beginning. So we're going to work in quadrant 1 and quadrant 4. Why am I working in quadrant 1 and 4? It's because I don't look at this step. I look at the step after we've changed everything, and I don't see any negatives. There's no negative in the front here, and there's no negative in the front here. Yes, there was a negative there, but we look at the part once we've changed it. Okay, so we start off by saying x plus 60 equals and x plus 60 equals. Now for quadrant 1, you don't have a 180 minus or 180 plus, so you just put your reference angle, which is this. And then we say plus k 360, k element z. And then for quadrant 4, we're going to say x plus 60 equals. And then for quadrant 4, we say 360 minus. Then in brackets, you put your reference angle, must be in brackets. And then you say plus k 360, k element z. All right, now let's go solve. So at number 1, you're actually going to get a no solution. Why? Because when you take this x over, it becomes x minus x, which is just 0. And then 90 minus 60 becomes 30, plus k 360. K is an element of z. So this is just no solution. And that does happen sometimes. Okay, with this number 4, if you don't mind, I'm just going to move it up to the top over here. And so we're going to end up with x plus 60 equals to 360 minus 90 minus x plus k 360. K is an element of z. Okay. And now we're just going to solve for x. I'm going to bring this x over to the left, so we end up with a 2x. Then on the right-hand side, we'll have 360 minus 90 minus 60 plus k 360, k element of z. And so we're going to end up with 2x is equal to 210 plus k 360, k element z. It's so annoying having to write that stupid k element z. And then if you had to divide by 2, you'll get x equals to 105. And then you also divide this by 2. That is important. Plus k 180. K element z. Now, we are not done. Why? Because this is actually not a general solution question. Why do I say that? Because they've given us an interval. So we need to go get the exact answers. Okay. So let's quickly write down our 2 answers. Oh no, we only got 1 answer. The other one was a no solution. So we've just got this over here. Okay, so the way that this works is you just go plug in random numbers for k. So let's start with k equals to 0, and let's see what happens. So k is 0. So it's 0 times 180. That's just going to give us 105. Now what we do is you say, is 105 inside here? Yes, it is. So that's a good one. Lovely. Let's move on. Let's try k equals to 1. So that means x equals to 105 plus 1 times 180. How much is that? 285. 285, which is too big. They said the answer must be there, so this one is not good. Okay, so now we go back down to k equals to minus 1. Let's try k equals to minus 1. So that would be x equals to 105 plus minus 1 times 180. And if we had to work that out, we get minus 75. Is that too big? No, it's not, because it's still inside here, so that's a good one. Then we can go k equals to minus 2, and let's see. I think this one won't work, but let's try. Okay. and you get minus 255, which is way too big. Whoops, 255. That is outside of this range, or interval, or domain. Okay, so we can say no. So what are the correct answers then? The final answer is going to be x equals, then we open up these funny brackets, and we can just say minus 75, and then 105. And then close. Now, what's interesting is that these are the two graphs. You know how? Okay, so let's just think back of the previous question. We had this graph, and then we had the graph of minus sin x. But if you take the sin x over, like we did earlier, look at that. Look at that, guys. These are the two graphs that we had earlier in the previous question. Let me go back and remind you. Sorry, it was this question here. We had cos x plus 60. Okay, I erased the previous part. But do you remember what this red graph was? What they asked us to draw? They asked us to draw negative sin x. So what they're actually asking us to do is to find out where the two graphs intersect. Where the two graphs intersect. And how many places do they intersect? Well, we got two answers. So let's go back to those graphs and see if that makes sense. Well, we know that they intersect here. Okay, so that's obviously the minus 75 value. And then they also intersect over here. And that would have to be the 105 value, which we just worked out over there, guys. You see, so what they were actually doing is just getting us to find out where the two graphs intersect each other. Hope that makes sense. Okay, so we know that these graphs now intersect at negative 75, and then over here at 105. Now the next question says, determine the values of x for which this graph plus this graph is bigger than 0. Now that looks scary, right? But guys, they're just playing mind games with you. All that you do is the following. So let me just write this down for us. All you do is you just take the sin to the other side. Ooh, look at that. Suddenly, we have the two graphs that we have over here. Remember that this black original graph is the cos x plus 60, which is that one. And then the red one is the negative sin x that we were asked to draw earlier. So they're actually just asking you, where's the cos graph, which is the black one? Where is that bigger than the red one? That's what they're saying. When they say bigger than, it means above. So what they're saying is, where is the black graph, or the cos graph, above the red one, or the sin graph? That's what this question's actually saying. So where is the black graph on top? Well, that would be over here, all the way up to there. That's where the black graph is on top. So if we had to now go answer that, we could just say, so we could say that x must be bigger than minus 75. We won't include it because they haven't included it here. And then it goes all the way up to this point, which is 105. Now, if you want to use interval notation, you could just say x is an element going from negative 75 up to 105, like that. The function g can also be defined as y equals to negative sin x minus theta, where theta is an acute angle. Determine the value of theta. Okay, so this is a weird question. I wouldn't stress so much about it, but let's just see. What they're pretty much saying is that the function g, which is this original black graph that we have over here, they're saying that that can also be written as a negative sin graph. And you can see that this red and this black graph, can you see that they're very similar? They're very similar. If I draw this correctly, it could even go something like this. Okay, I don't know what I achieved there, but can you see that the red and the black graph are almost the same? Like if you just had to take this red graph, if you just had to move it up a little bit, just move it up a little bit to the right, then it would be the same as the cos graph. This part would be here. If you move all of those points over to the right hand side, it would become the cos graph. So they're saying that the graph G could also be written as a sin graph, or minus sin, because that's what we have here, right? But then it would have to be moved a little bit to the right, and that's what they're trying to show us over here, that we should just move it a little bit to the right. So let's try to think about how much. Well, we can just look at this turning point. This turning point is at minus 90, but the cos graph is at minus 60. Okay, so we would have to just take this sin graph, which is the red one, right, and then just move it up 30 degrees to the right. So your equation would be y equals to negative sin x minus 30, because then it would move the red one 30 degrees to the right, and then it would actually be on top of the cos graph. So the answer for this one is 30 degrees.
So what you'll see with this question is that everything that they've mentioned here is already on the diagram. Okay, so it says the first question, determine the value of cos theta for 4 marks. Now, what's interesting is that, sorry, not interesting, I don't know why I said that, but what I actually just wanted to say was that this is not a 90-degree triangle. So when it's not a 90-degree triangle, then you don't use the grade 10 formulas. So you don't use grade 10 formulas. Now, what are those? You know, like SOHCAHTOA, like sin equals to opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Those only work with 90 degrees. Okay, so we won't use those formulas. So we are only left with the grade 11 formulas. So a over sin a equals to b over sin b. Or there's that cos rule, which is c squared equals to a squared plus b squared minus 2ab cos angle C. So because they were wanting the value of cos theta, I would imagine the best approach would just be to use this one. So what we must remember about this formula is that the way it works is the following. You need a triangle, obviously, hey? And what you do, okay, so you need an angle, so theta, and then you've got these 3 letters, A, B, and C. Okay, so that's the kind of setup that you need, okay? So we've got that here. We've got this angle, and we've got these 3 sides. Now, the way that it works is that in this formula over here, this is the angle, and then this side here must be opposite the angle. So here's our angle theta, and then this side is the opposite one. Okay, so when we go fill that into the formula now, you start off with the opposite one, or the one that's opposite the angle, and so that would be the y, but it's to the power of 2, equals. Now here's where students make a lot of mistakes. The a and the b, they are the two sides that are next to the angle. Okay, students understand that part, but then they do this. They go 2y and then they say squared. And then they forget that it should be 2y in a bracket squared, so that later on this can actually become a 4. Whereas if you just left it like that, you might just say that it's 2y squared, and it won't become 4y squared. Okay? I'm going to do the next one. So that's that part there. Then we're going to say minus 2. Then we're going to just fill in those 2 sides again. And then we're going to say cos. Now the angle is called theta. What we'll do next is we'll just take these 2 to the other side. So we can say y squared minus 4y squared minus 4y squared equals to minus 2. Actually, let's just multiply these 3 together. So 2 times 2 times 2 is 8. Y squared cos theta. And then on the left-hand side, we would end up with y squared minus 4, which is minus 3, minus another 4, which is minus 7. There we go. And now we just get cos theta by itself, because that's all that they want. Get cos theta by itself. So we say minus 7 squared over minus 8 y squared. And the y's cancel, the negatives cancel, and so you're just left with 7 over 8. Then the last one. If QR, okay, so where's QR? Okay, it's there. If QR cuts the circumference of the circle at T, okay, so that means that is called T. Determine the length of PT, determine PT in terms of y and theta. Okay, so PT would be this one. And they want us to just work out what that is. So it says determine PT in terms of y and theta. Okay, so this looks 90 degrees, but it might not be, although it could be, and in fact, it is. Why? Well, check this out. This is the diameter. Right? That is the diameter. So if we make a triangle here, we know that a diameter always makes an angle of 90 degrees on the circumference of a circle. You know, angles in a semicircle. If you have a diameter and you make an angle on the circumference, it'll always be 90 degrees. You can even try this at home by yourself. Go draw a circle on your page, draw a diameter, and then try to make any other angle, it'll always be a 90. Don't believe me? Well, let's make a line that's not the diameter. Okay, so that's not the diameter. Try make an angle. That's not 90 degrees. So, okay, so we know that this is 90 degrees then. So we can say then, let's just say that angle PTR is 90 degrees. Why? Because it's angles in semicircle. Okay, that's that whole angle semicircle reason. So now we could use old school grade 10 formulas, but I know a lot of you grade 11s and 12s, you guys just forget about the grade 10 formulas, and a lot of you just want to use these ones. And it's okay, you can. So in fact, what I'm going to do, from experience, I just know that I know, most of you are going to try use these formulas. But if you are a student who's using the grade 10 sin, cos, tan formulas, that's perfect too. You'll get the same answer. And in fact, it'll be a bit faster for you. Okay, but I'm going to use the typical grade 11, grade 12 approach, which is to use the sin rule in these types of scenarios. So we're looking for the size PT. So that's the one we're looking for. We do have an angle opposite that one, which is great. And then we could just use this 2y opposite the 90 degree. That's fine. So we could say A over sin A equals to B over sin B. And then we could say that that's going to be PT over the sin of its angle, which is the opposite one, which is theta, would be the same as 2y over the sin of its angle, which is 90 degrees. Like that. Okay, so that's PT over sin theta equals to 2y over the sin of 90. Now the sin of 90 is just 1. Okay, now we're just going to get PT by itself. So to do that, we're just going to multiply the sin theta across. So PT would end up becoming 2y multiplied by sin theta. You can say over 1, but 1 is just, you can just ignore it, right? So PT is just equal to 2y sin theta.
A cylindrical aerosol can has a lid in the shape of a hemisphere that fits exactly on the top of the can. The height of the can is 16 and the radius of the base is 2.9. Okay, so some learners are going to say, they're going to be like, sir, why are you giving us the formulas? But I'm not. These formulas were given in the exam. So sometimes, not always, but sometimes, when it's a type of question where it's a complicated shape like this, they actually give the formulas. Okay, so should you study the formulas? Yes, you probably should, but sometimes they are nice and they just give you the formulas. I think they should always give the formulas, but anyways, that's a topic for another day. So let's see what they ask here. For 5 marks, calculate the surface area of the can with the lid in place as shown in figure 1. Okay, so they just want the total surface area. Now, there are some interesting things that are going to take place, so pay careful attention. So, at the bottom of this can, that's a circle, right? So this is the way I do surface area. I don't use fancy formulas. I just do the following. So at the bottom of the can, we have a circle, okay? So that circle, so I'm going to say surface area, is going to be a circle that's at the bottom. Then we've got this stuff on the outside. You know, the part that goes around the outside. So the way that you get that is you just take the circumference of the circular part, okay? Those are the circular parts. And then you just drag the circle all the way up to the top of here. So you're just taking all of these circles, and that's what we're doing there. So you take a formula of a circle, and then you just times that by the height. See, because they didn't even give a cylinder. But if they did give a cylinder, the formula of a cylinder is normally, be careful now, 2 circles, so 2 pi r squared. And then there's that circular part that I was talking about over here, which is 2 pi r h. But many learners, they'll just go use these formulas directly, but they fail to understand that a cylinder has 2 circles, right? A top and the bottom, and that's where this comes from, 2 pi r squared, because pi r squared is 1 circle, and then there's 2 of them. But in this question, we're not going to try to calculate this circle. Why? Because they want the surface area of the outside. So they want the whole can, but of the outside, not the inside. So that's why I don't have a 2 here, because then I would be adding 2 circles. So that's what I've got here. So this part here is this part on the floor. Okay, there's like a circle part there. And then this part here is everything on the outside. Okay, like all of that on the outside. Okay, it's difficult to show. Now we're going to look at the sphere part. Now, they have given us a sphere, right? Which is 4 pi r squared. But we don't have a sphere, we have a hemisphere. So we're going to divide this by 2. So we're going to divide that by 2, so 4 pi r squared, but then we're going to divide that by 2. Okay, and so now it's pretty straightforward. We just go calculate. So the radius is 2.9. The height is 16 of that cylinder, and then plus 4 pi 2.9 squared over 2. And then we're just going to go fill that all in. And we should get a final answer of 370.80. And I think they used centimeters. Yes, they did. So we'll say centimeters squared. See, they did use centimeters over there. The next one says that if the lid is 80% filled with liquid, as shown in figure 2, calculate the volume of the liquid in the lid. Okay, so I'm a bit confused, like what type of deodorant can this is. Like I thought the liquid gets filled in the bottom here. But anyways, let's not think about that too much. They just want us to know, imagine you had a lid. Okay, so remember this is just a cross section, but it's actually this one over here. And that's filled up to 80%. Okay? So all we're going to do, guys, is we're just going to go, we're going to pretend that this was a complete sphere because they've given us the volume. So volume of a sphere is 4 over 3 pi r cubed. Let's just go work that out. So 4 over 3 pi. Now the radius is 2.9. And let's just work that out. And so I'm not going to round off because this is not the final answer. So that's 0.1604043. But then we're going to divide that by 2 because we have a hemisphere. So we have a hemisphere. So we're going to divide that by 2. Which is then 51. This is not the final answer. 51.08020215. And then we're just going to see what is 80% of that. Because we've worked out the hemisphere now. But now we just want to get 80% of that. So we can just say 80% multiplied by 51.08020215. And if we work out that, we get 40.86. And that would be in centimeters cubed. In the diagram, O is the center of the circle. Okay, diameter LR subtends LKR at the circumference. N is another point. L1 is 58. Calculate with reasons the size of angle LKR. So LKR is this angle over here. Now that angle is 90 degrees. Why? Because it is subtended by the diameter. Remember, this is the diameter. They told us that. So that angle is made from that diameter. So remember, when you have a circle and you have a diameter, then any other angle that you make with that diameter is always 90 degrees. We call this the angles in a semicircle. So the answer here is 90 degrees. And then you must give a reason, and that would be angles in semicircle. Okay, now the next part, the value of angle R. Okay, so angle R is over here. So we now know that, well, we can work in this triangle here, and we now know that that's 90. So then we can just use some angles in a triangle, because that's 58, to find this missing angle. So we could just say, so we'll just say that angle R is equal to 180 minus 90 minus 58, and that's just sum angles triangle. And so angle R would be 32 degrees. And the last one, angle N. So this is this one over here. So remember, whenever we see like a bow tie, you know, a bow tie that people wear to like a dance or whatever, you can see the bow tie here. or some people call it the butterfly. But if you see the butterfly, then these two angles are always the same. And then these two angles, they are always the same. So if we've just worked out r as 32, let's do that in red, then that means angle n would also be 32. So that would be 32 degrees, but then the reason would be angles in same segment. Okay, so don't call it the butterfly, don't call it the bow tie, just say angles in the same segment. In the diagram, O is the center of the circle, ABC, okay, I'm going to look for important things here, chords, blah, 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 A is X. Okay, so everything that they've told us here, we can see that on the diagram. The first question says, determine the size of angle O1, so that's this one here, in terms of X. And then the next question is the proof. Okay, so if you've watched any of the videos, or if you understand the proof of proving this theorem that looks something like this, the theorem which tells us that this angle is always going to be double this angle, then you should have a fairly good idea about how or what we are going to do here. Okay? So what we can do is we know that in this triangle over here, these two lines are exactly the same length. They are radii. So that means that this angle here is also going to be x. Okay? But let's first tell them that. So we're going to say that OA is the same as OC because they are radii. Then we're going to say that therefore angle A is going to be the same as angle C1, and that's just because of angles opposite equal sides. Okay, so then that means that angle C1 would have to be x. Okay, so that's x. Now you can do the next part in two different ways. So you see we have this triangle over here, right? Now some learners are very comfortable with external angle of a triangle. And if you are comfortable with external angle of a triangle, you should know that this angle on the outside is the same as the two angles on the inside added together. Okay? So some students like that approach. What other learners like to do is they first like to go work out this angle over here by using sum of angles in a triangle. And then what they do is they use the straight line, which is over here, and then they use that straight line to calculate O1. Both methods are perfectly correct, and you will get the same answer. I'm just going to use the first one because it's a little bit faster. So once again, remember, in general, that if you have a triangle, and if you have, let's say this is X and this is Y, and then you've got this part here, then this angle on the outside, let's call it A. Then A is always the same as X plus Y. Okay? It's called the external angle of a triangle. So angle O1 is then going to be angle A plus angle C1, and that's because it's the external angle of a triangle. And so angle O1 is then going to be X plus X, which is 2X. Okay, so we've worked that one out as 2X. Next question. Hence, prove the theorem that states that the angle... Okay, so blah, 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 blah. They want us to prove that this angle is double this angle. So what we do... Okay, so what I want you to think about is we've done everything on this side, and that was all using X. Now we're going to do everything on this side, and that is all using Y. But we're going to do the exact same thing. So we're going to say that OB is the same as OC. Y, radii. Okay, so what I'm saying is that this length is the same as that length over there. Then we're going to say that angle B is the same as angle C2 because of angles opposite equal, whoops, you can rather say equal sides. Okay, so angle C2 is Y. Okay, so we've got that as Y. Then we can calculate O2 using external angle or exterior angle of a triangle. So we can say that angle O2 is then going to be equal to B plus C2, and that's because of exterior angle triangle. And so O2 is going to be 2Y. Okay, and so now we have that. Now, have a look here. If we're to add these two together, so I'm going to say over here, let's actually clear up some space. Okay, so what we can then do is say that angle O1 plus angle O2 is equal to 2x plus 2y. So I'm going to take out a 2 as a common factor, and then you're left with that. Then if you look at angle C1 plus angle C2, that's going to be x plus y. So can you see that this angle is 2 times x plus y, but x plus y is also this one over here. So what we are saying is that this angle is 2 times this angle over here. So we can say, therefore, AOB, angle AOB, is 2 times angle ACB. In the diagram, PQ is a common chord. Okay, so PQ, what they mean is that PQ is a line in both circles. The center M of the larger circle, okay, so that's the center of the larger circle, lies on the circumference of the smaller circle. Okay, so we can see that M is also on the smaller circle. Okay, it's not the center of the smaller circle. PMNQ. So where is, oh, there. PMNQ is a cyclic quad in the smaller circle. Yes, that's obvious because it's got 4 sides, 1, 2, 3, 4, and they're all touching the edges of that small circle. QN is produced, okay, to point R. NM produced meets the chord PR at S. Oh, sorry, I yawned, guys. And then P2 is equal to X. Okay, so the rest isn't that important. Right, so the first question for only 1 mark. Give a reason why the angle N2 is equal to X. Right, so remember they told us that this shape here is a cyclic quad. Now we know that when you have a cyclic quad, well, let's make it a bit of a more weird one. Okay, we know that if it is a cyclic quad, then the exterior angle is always equal to the interior opposite angle, which is that one there. They are always the same. So if you look at angle N2, it's the exterior angle. So that means that it's equal to not that one, but the opposite one. Okay, so that is what's happening there. So we can just say exterior angle cyclic quad. Ooh, that's not how you write cyclic. Exterior angle cyclic quad. Next one, write down another angle that is equal to x. Okay, so another angle. Okay, so let's get rid of that now. So we know that this one is x. Right, so if you had to have a look at the big circle, okay, so only fix your attention to the big circle, which is centered at M. So that means that this line and this line are the same. They are radii. So we can say that MP is the same as MQ, and that is because they are radii. Now remember, that then means that if we had to look at this triangle here, let's make that a bit better, then it means that this angle here, which is Q1, must be the same as P2. So therefore Q1 must be the same as P2, and that's just because of angles, opposite, equal, sides. And then if you had to, you could then say therefore Q1 is equal to X, because P2 is X. Okay, so there we got our other angle, so that's X as well. So this one's done, and this one's done. Okay, that was meant to say give a reason, but anyways. Okay, 10.2.3, determine the size of angle R. Determine the size of angle R, and that's for 3 marks. So what we can now do is inside this triangle over here, we could work out the value of angle M1. Okay, so angle M1 would just be 180 minus x, and that's just because of sum of angles in a triangle. So that means that angle M1 would be 180 minus 2x. Okay, so M1 would be 180 minus 2x. Now, if you look at angle M and angle R, there's that whole thing that's happening there where the angle at the center is 2 times the angle at the circumference. Because you see, if you take this chord here and you make angle M like that, well, that chord can also make angle R. Okay, so you know the one that looks like this. So this angle here at the center is always double the angle at the circumference. Okay, so this one's double this one. So we can say that angle R must be a half of angle M. That's the same thing, right? saying r is half of m1 or m1 is double r. It's the same thing, and that's just because of angle at center equals 2 times angle at, and then circumference. Okay, so angle r is then going to be a half of 180 minus 2x, and so if you had to multiply the half in, you should just get 90 minus x. So angle r is 90 minus x. Then the last one says prove that the length of PS, okay, so PS is over here. Whoa, what happened there? PS and SR. Where are you, SR? Oh, SR is that one. Let's do it in a different color. So they want us to prove that these two are the same. So what I think we can do, let's quickly go work out the value of angle S2 because we have this triangle. Okay, so just once again, in this triangle here, that's the one I'm working in now. So we could say that angle S2 is 180 minus 90 minus x. Always put that in a bracket because it's more than one term. You see that? And then minus x. This minus x, I don't need to put that in a bracket. You can if you want, but it's only one term. But if you don't put a bracket here, it makes it completely, or it makes everything wrong. Okay, so what we get is 180 minus 90 plus x minus x. So the x's cancel, and this means that angle S2 is 90 degrees. So, do you remember one of the very first circle theorems that we ever learnt about? It is the one where you have a circle, and you have a center, you have a chord, and you have a line that hits that chord at 90 degrees. What does that do? Well done if you remember that it means, or what it means is that it divides this chord AC into two equal parts. So it means that AB and BC are exactly the same length. Okay, we call that the line from center perpendicular to chord theorem. So if you look at the big circle, okay, then we have a center, which is M. Then we have a line which is hitting this chord PR. See that? Let me do that again. We're hitting this chord over here. And we've just calculated that this is 90 degrees. So we are hitting the chord at 90 degrees. So what that then means is that PS must be the same as SR. That is a circle theorem. Okay, so the way that you'd answer this then is you'd first go work out the 90 degrees, and then you would say, therefore, PS is the same as SR because we have a line from center which is perpendicular to chord. In the diagram, the vertices A, B, C are concyclic. Now, I'll be honest with you, in all my years of teaching, I've never heard that word before, so I had to quickly go research it. Don't know why they're trying to be so fancy. It just means they're on the same circle, okay? So EB and, okay, then they said that EB, where are you, EB? There you are. EB and where's EC? There you are tangents to the circle. T is a point on AB such that TE is parallel. Okay, so they parallel, and then that's all fine. Then the first question. I forgot the mark allocations here, but I did go have a look at them quickly. I just couldn't, I didn't have time to put them in, but this one is worth 4, and this one is also worth 4. Oh, by the way, these questions do carry on. We've got more questions on the next slide, 11.3, 11.4, and 11.5. So it says that prove that B1, where are you, B1? Is equal to T3. T3, where are you? There you are. Okay, I saw it. It's a pretty quick one, actually, guys. So what we know is that you could use C3 or you could use B1, but I'm going to start with B1. Now, B1 is the angle that is between a tangent and a chord. Now, remember, when you have something like that, where you have a chord, a tangent, and an angle, then you must think about the tan-chord theorem. So what you do is you take one of your fingers and you place it on the C over here, which is the one side of the chord, and then you place another finger on the other side of the chord. And then you try to bring your two fingers to touch each other, or to get to the same place, for example. So, for example, some of you might say, okay, well, my two fingers could obviously go along those two lines and they would meet up over here. Now, that's not wrong, but that's not what we want. We want them to come together somewhere on the edge of the circle. So go along this line with your fingers, or one finger, and then go along this line with the other finger. Bam! There we go. So that means that angle A, is the same as angle B1 because of the tan chord theorem. So that's the first thing we could say. We could say that angle B1, let me write in red, is equal to angle A1, and not A1, just A. And that is because of the tan chord theorem. Okay, so that's the first step. The next thing is that, I don't know why this is worth 4 marks. This is pretty straightforward. It's not a lot of steps. Look at these parallel lines. So can you see there's a corresponding angle over there? So we can then say that angle A is the same as angle T3. And that's just because of corresponding angles. So we can say corresp angles. And that's just because the line TE is parallel to AEC. So therefore, angle angle A is equal to angle T3. So now, can you see the match over there? So we just said that angle B1 is the same as angle A, and then we said that angle A is the same as T3. So the logical conclusion from that is that therefore angle B1 must be the same as T3. And there's no reason for that part. That's just a conclusion from the steps we've already said. Okay, so for 4 marks, not that many steps. I went and looked on the memo just to see how the whole 4 marks was, and for this one they did one for the statement and the reason, then the statement and the reason. That's where the 4 marks came from. Okay, so just remember that these two are the same. They possibly might ask us to, or we might have to make use of that in later questions. The next one says prove that TBEC, so let's go TBEC is a cyclic quad. All right, so how do we prove that something is a cyclic quad? Well, 3 different ways. Let's actually just do here and then here. Okay, so the first one, most basic one, is if you have a cyclic quad, or if we're trying to prove that it is a cyclic quad, then if the opposite angles add up to 180. Okay, so if those add up to 180, actually let's just say A and B, so A and B. So if A plus B equals to 180, then it's a cyclic quad. Next one, if the exterior angle is the same as the interior angle, so if they are equal to each other, then it's a cyclic quad. Now listen up. The third one is the most popular one, and it goes like this. It's usually when you have some type of cyclic, or they say it's a cyclic quad, or we're trying to prove it's a cyclic quad, and then it's got lines going across like this. Okay? If that happens, and look here, we also have that happening over there, then usually it's going to be option number 3. So how does it work? Well, it's the angle in the same segment theorem. So what you try to do is you either try to show that these two are the same, or it could be these two that are the same, or it could be these two that are the same, or it could be these two that are the same. See, it's like the whole bow tie thing. See there? So you've got, okay, so it's, whoopsie. So it's the bow tie that is going on, okay? So in this diagram, what that would mean is that it would either have to be this one and this one that are the same, okay? Because that's like a bow tie over there. Or it could be like, for example, this one and this one. Or it could maybe be this one and this one. Or it could be this one and this one. So it's the whole bow tie thing happening. How am I finding those little angles, by the way? It's very simple. Let me show you. I start off with a single chord. So maybe I start off with this side of here. And then what I do is I just try and make angles with that. So I can make an angle there. So that one. And then I try and make more. So I go there and there. So it would be that one. So it would be those two. Okay? So that's sort of what I'm doing. And then what you do is you'll just go to this one and do the same thing. And then you go to this one and do the same thing. And then go to this one and do the same thing. So those are the different pairs that we could get. So my advice is that if there's a shape that has some lines going through it, then it's normally going to be number 3. And that's where I would always start. Alright, so this is actually quite an easy one. So these lines, BE and EC, they have the same length. Why? Because they are tangents that come from the same point. Remember they told us that they are tangents. Where did they say? EB and EC are tangents, and they come from the same point. So EB is the same length as EC. Why? Tangents from common point. Okay, so what that then means is that in this triangle over here, this angle and this angle would be the same, just because of it's an isosceles triangle. So we could say that angle C3 is then the same as angle B1. That's just because of angles opposite equal sides. Okay, if you're in the IEB curriculum, you are able to just say isos triangle, but in the CAPS curriculum, they are not allowed to do that. Okay, so C3 and B1 are the same. There we go. Now, all of a sudden, these two angles are the same, because we knew from earlier that these two were already the same. Now, that is exactly what we wanted, because if I then actually look at this cyclic quad, and I use this chord as my reference, then look at the angles I can make. Let me show you. I can go this way, and I can make this angle. Okay? So I made this angle. And then I could also go this way, and I could make this angle. So if those two are the same, then it's a cyclic quad. And boom, they are the same. So it is a cyclic quad. So what I do now is I say, therefore, angle T3 is the same as angle C3. Therefore, this thing TBEC is a cyclic quad. And the reason is it's the converse of angles in the same segment. Now, for the next questions, always remember everything that we've already proved is the same. So, for example, we know that this angle is the same as this angle, which is the same as this angle, which is the same as this angle. We also proved that this shape here is cyclic, because we might need to use this information again, okay, in the next questions. So the next one, for only 2 marks, prove that ET, where's ET? ET, there you are. Okay, so ET bisects angle BTC. BTC, okay, let me get a different color. So here's BTC. So they want us to prove that this purple line bisects that green angle. So what they're actually saying is they want us to prove that these two angles, T2 and T3, are the same. That is what they are actually wanting, okay? So they don't write this in the exam, but this is just for us. They actually, or what I have to write like that? To say goal. Our goal is prove that T2 is the same as T3. That is what we would love to be able to do. And look how easy this is. Remember, it's a cyclic quad. Now, whenever you prove something's a cyclic quad, very often they like to ask questions about that afterwards. So if you use this as your chord in that cyclic quad, then just go do the whole angles in the same segment. Well, that would take you there. And then if you do another one from the same chord, it would go there. And those two have to be the same. But this one already has that little red dot, which we've proved earlier. So that means that T2 is also going to have a little red dot. So it's also going to be the same. So what we can say is that angle T2 is going to be the same as angle B1, right? We just showed that these two are the same. Why? Because it's angles in the same segment. We can say that because it is a cyclic quad. And when it's a cyclic quad, all of those properties are now true. So we know that T2 is now this one. And then we can just say, therefore, T3 and T2 are the same. Because we already proved way earlier that T3 and B1 were the same. We did that in previous questions. So we can then just say, therefore, T3 is the same as T2. Okay? And then we can just say, therefore, ET bisects BTC. Next one, if it is given that TB is a tangent to a circle through BFE. Okay, so TB is a tangent to the circle through BFE. Okay, so we've got to go make a nice triangle through BFE now. Okay, so something like that, okay? So what do they want? If it is given that TB... Oh, they're saying TB is a tangent. Okay. So TB is a tangent. Hashtag tan chord. Just saying, just saying. Here's a tangent. Okay, so that line is a tangent. Prove that TB and TC are the same. TB and TC. Okay, so they want us to somehow prove that this length is the same as this length. Okay, so what that... well, usually, if two sides are the same, like if let's say this one is the same as this one, then it's usually because these two angles are the same. Okay, so that's probably what we're going to do. So if we want to prove that TB and TC have the same length, then it would mean that this angle and this angle, because that's inside this triangle, they would probably have to be the same. And that's possibly what we're going to have to go and prove now in this question. Okay, so I would go straight for that tan chord theorem, and that'll probably be our fastest method, or exactly what we need to do. So how does the tan chord theorem work again? Well, you need three things. You need a tangent. We've got that. Then you need a chord. Okay, let me do it in green. We need a chord. And we need an angle, which is in between the tangent and the chord. So from that, you can use your tan chord theorem. So remember, we're only working in this red circle. We're not working in the big circle. So you take your fingers, or a finger, and you place it on one edge of the chord, and then you place your other finger, or a different finger, on another edge of the chord. And you try and make those two fingers come together at a point on the edge of the circle. So for example, you could go there, and you could go there. Okay, so E2 is the angle. So that means that E2 and B2 are the same. So let's start there. I don't know if that's going to help, but I think it probably will, because it's usually what happens. So E2 is the same as B2, and that's just because of the tan chord theorem. Okay, so those two are now the same. Ah, okay. And then what I noticed immediately was that these two things here seem to be sticking out somehow. So remember that that cyclic quad we found out earlier? So this is the lesson for you guys for this video. If they've asked you to prove something in the past, don't forget it, because they like to come back to it, especially these cyclic quads. So because it's a cyclic quad, we can use angle in the same segment. So if you use this as your chord, then check the different angles you can make. If you go this way, you can make this one. It's the bow tie, guys. You know the bow ties? And then if you go this way, then you could make this angle over here. So those two are then the same. So we could say that angle C2 is equal to angle E2. And that's just because of angles in same segment. Some of you might be like, yeah, but this isn't even a circle. I understand that, guys, but if it's a cyclic quad, then it classifies, you can use these rules. It doesn't have to be in a circle for it to be only, it doesn't have to only be in a circle for it to be a cyclic quad. Okay? Right, and so once again, if you look carefully at what we've done here, we started off by saying that angle E2 and B2 are the same. So B2 and E2, we said that they were the same. Then we said that C2 is the same as E2. So because E2 is shared by both, then we can say that these two are now equal. So we can say, therefore, C2 must be the same as B2. And there's no reason for that. That's just from the previous statements. And that's what we originally wanted, guys. Remember, we wanted to show that this angle was the same as this angle. Because if this angle is the same as this angle, then it means that in this triangle, these two lengths would have to be the same because of angles opposite equal sides. So we can say, therefore, TB must be the same as TC. But don't say angles opposite equal sides. It's because they are the sides that are opposite equal angles now. Okay, they are the sides that are opposite equal angles. The last question says, prove that T is the center of the circle. Okay, now this question I don't really agree with because they don't really teach us this, but for something to be the center of a circle, it has to obviously, it has to be the same distance from 3 different points. So for example, if that's A, that's B, you need a third point so all 3 of these must be the same length. Then we can say it's the center of a circle. It's not enough to only have 2 points, because I could, for example, say that this is the center because these 2 are the same, so they're the radii, but that doesn't make any sense. So you need a third point as well, and you can see that that's not the same length. So it has to be from 3 points, a minimum of 3. So there, and then there, for example. If you can get 3, then it's the center. Because what some learners might do is they'll say, oh, okay, it is the center. Why? Because this length is the same as this length. Because we already proved that these 2 are the same. But that's not true. You need at least 3. Because as I said just now, you could then say that this is the center because these 2 are the same, radii. But that's not true. Okay, so it's not going to be difficult though, because what we can do now is we're going to go for this one here. We're going to try to see if this one is the same as this one. Because if this one is the same as this one, and this one is the same as this one, then all 3 of those are the same, and then we're good to go. So let's try see if this side here, is the same as this side. And the way that we do that is just using angles. So let's go for C1. Let's see if we can find C1. So, okay. These are parallel lines, right? So we can just use alternating angles there for T2 and C1. So we can say that angle T2 is the same as angle C1. And that's just because of alternating angles, because of TE being parallel to AC. Okay, so they are the same. And then it's easy. Because these 2 angles are the same, then it means that these 2 sides have to be the same. So therefore we can say, therefore, angle T, or sorry, no, length TA would be the same as TC. Why? Because they are the sides that are opposite equal angles. Okay, so these are the same. And so there we have it. We can see that the point T is the same length from A, same length from C, and the same length from B. So then we can say, therefore, T is the same length, or the same distance, from A, B, and C. Therefore, T is the center of circle. If you didn't understand this last one, I wouldn't worry too much about it. I've never seen them ask something like that before. It is a bit of a weird question because they don't really go through that in class. So if you did struggle with this last one, 11.5, I really wouldn't stress too much about it.